Okay, so what we're gonna do is we're just gonna continue on with examples 4 and 5 and then finish this off. And I'm gonna try to record if you are working ahead, if you are ahead of, with all of these and you're comfortable, you understand what you're doing, I go ahead and feel free to work on that hand-in assignment. If you want to listen to our conversation, of course, we have this to get us go through all of our practice. So in example number 4 on page 14, it says here, enter the data and examine the scatter plot. So this is what we had to do. We had to enter the data. Okay. I could already see that in my calculator, there's already data in this. And how do I know that? Because I can see that in my graph, there's already points plotted in here. So what I need to do is I need to clear that. So stat, and then we're gonna press 1 for edit because we're gonna edit our list. Press 1 for edit. On our list 1 and list number 2, okay, we can then type in our X values on list 1 and Y values on list 2. Seems like nobody touched my calculator since yesterday because I can see that my points are still here, my data are still here. If yours is not there, go ahead and type those values on L1 and L2. Yeah. Okay, are you done entering their data? Okay. So enter your data on L1 and then what we had to do is we had to analyze. You had to analyze to see if you had to analyze to see what kind of window we're gonna set this up in, right? And then you, because this is quite deceiving, okay? Well, not deceiving, but it kind of gives you a hint that your graph is gonna be within quadrant 1. But sometimes we don't know if we're focusing on quadrant 1 or quadrant 2, quadrant 3, and so on. So the way we discuss this is that you look at the shoe size. Okay, these are all positive. Your X values are all positive. your y values are all positive, that means we are focusing on quadrant 1. And then from there, what we need to do is we can figure out what's our x min, what's our x max, what's our scale, what's our y min, y max, and y scale. So looking at this, okay, these are my x values typed in L1. These are the y values typed in L2. So look at this part. We can say x minimum is 0. Okay, so we're putting a 0 there so that we can actually see the x-axis, right? And the y-axis. And then the x max rather is 15. Now we chose 15 even though it's 12 is our maximum here. We chose 15 so that there's a little bit of space along the top. And then what would be the appropriate scale? The appropriate scale, we should go up by either 1 or you can go up by 2. Okay, those are the appropriate scales because it's not that from 0 to 15. It's not that big of a data. And then this part in here, you have y min is 0 as well, y max is 10, and then y scale is 1. So when we type that up and graphed it, we can see that it doesn't quite follow a trend. There's no trend going on in here. Is it increasing? Is it decreasing? What's going on? It's pretty much all over the place. So we can say that no, there are no trends, no relationship between shoe size and the number of pairs owned, and also the zero correlation between, there's no relationship between those two. So we've done this on a graphing calculator. How do we do this on just a regular paper?
The digits when I press graph, it doesn't show.
Is that plot? It's off. Okay. So how do we show this on our grid? Okay. On a graph paper. On a graph paper.
So I go there or here on. Check it. Let me check it. So I just press. Is it okay? No.
Yep. It's one thing to graph it on the graphing calculator, another thing to learn how to graph it on paper. Okay? So totally different skill. Now, when you look at this part in here, we need to go from 0 to 15. I'm gonna ask you, can I go by 1? Would it be okay to go up by 1 or to have a scale of 1?
No, it's okay.
Okay, is it okay? Okay. Yeah, that would make our graph fit. It will make the graph fit in our graph paper. But look what happens, and I'm gonna do it on a piece of paper first. If I go by 1, what's gonna happen is I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our graph is only this small, right? It's like we're not utilizing the whole graph paper. Okay? So even though we did here a scale of 1 to fit it on our screen, Oh, I think you're supposed to look here. You're okay? Yeah, okay, sure, go ahead.
Sorry, I just can't concentrate.
Oh, yeah. Oh, yeah, sure. What we could do is we could, instead of 1, we could go and use the whole graph. Well, how do I use the whole graph? 0.5. Yeah, who said that? Show. Okay, thank you. Yeah, we can say that every second one would be 1. Okay, every second one is 1. So 2, 3, yeah. So our scale on a graph paper was a scale of 1. But the scale that we're using on a graph paper is 0.5. Because each one is worth 0.5. Okay? And the reason why we're doing that is so that we can easily graph our points. We're using the whole graph paper when we're doing this. Okay? We don't want our graph to be really tiny because it's hard to graph and hard to see the trend there. Okay. What about this one in here? On our calculator, we said the y scale is 1. But that's going to make our graph really tiny. So what we could do is we could also use a scale of a half. So that means every second one is 1. 2, 3, 4. Okay, so our x-axis scale, here has now been figured out. The y scale is figured out. Let's try to graph it then. A half. 0.5, yeah. Same 0.5. Yeah. Okay. Now we can go ahead and graph those data. So the first one is 8, 3. Okay, so 8, so starting at 0, 0, you go 8 on the x and 3 on the y. Just put one dot there. Okay. Yesterday, I saw some people. Okay, this is what I saw. They go 8, and then 3, and then they have a whole bunch of rectangles going on there. It's actually, you don't need that part. So make sure, so I saw some people doing that. I know that's what you're trying to do, is try to figure out or locate the point, but make sure you're not actually drawing the lines. Okay, because I saw some people doing the lines. Okay, no lines, just the point. So the next one is 11, 7. 11, 7. So where can we find 11, 7? Starting at 0, 0. Along the x is 11, and then 7, y. Okay. Let's do the next one. 6, 4. So 0, 0. start there, 6, and then 4. So don't draw the line. 12, 5. 12, so start at 0, 0, horizontally 12, and then up 5. So go ahead and finish it off. I'll do the same thing.
So we do all.
So that's, okay, I gotta make sure that all of them are there. So count the number of data set you have and then count the number of points you got, then it should be the same number. So 1, 2, 3, 4. There should be 6 data set. So when you look at the points, there should be 6 points. I'm gonna show you, gonna compare the two information side by side. So yeah, so I see that, yeah, they're pretty much, they're exactly the same. It's just different scaling. So we're using our graphing calculator. One strategy to use that, but it's a totally different skill set and strategy to do it on a graph paper. Okay? So what have we done? That creates a nice graph. Equal increments. So here our increments here is half each time. Every tick mark or every line is a half. Same thing with the y-axis. We got the label on the x-axis and label on the y-axis. We got the plots. And then finally, we need a title. So the title is pairs of shoes owned versus shoe size. Pairs of shoes owned versus shoe size. Okay. Is that good? This is example number 4.
Shoes owned versus shoe size. I didn't understand how can we say that. Can we say shoe size versus pair of shoes owned?
Yeah.
Is it okay? if
Yeah,
we
you can say that.
Okay.
But Merhawit, what we have here, normally we would go y versus the x.
Okay.
Yeah,
that's
how
what
the
I
y
wanted.
is related to the x.
Okay, so we have to
Yeah,
start with
that's,
y.
yeah,
alone.
y. Yeah. That's. Is that good? Yeah, for sure. Oh, like, oh yeah, that's what Merhawat was like asking. Can I start saying like shoe size versus pairs of shoes owned? We usually have this y versus x approach, like how y is connected to the x. Yeah. So, yeah, start with the y. Yeah. I think for science it's like that too. So, yeah. Okay. So now let's take a look at the next one, on example 5. Let's take a look at example 5, and here it says here, enter the data and examine the scatter plot. Anywhere. Good, thank you. Does it have a name? Yes. Awesome. Okay, enter the data and examine the scatter plot. So let's just do that. Okay, clear out the one that we have. So stat. I think everyone should be getting pretty good at what buttons to press, right? So let's enter the time and then the height of the ball. Oh. I'm just gonna wait until everyone's done entering the data. So you know what to press? Yeah. Okay. Have you used the graphic calculator before? Really? Okay. Just stop for a moment. I'm gonna show you something, okay? Because I'm gonna show you some possibilities where you're gonna see some kind of like, oh, there's an error, and then you're trying to figure out, well, what did I do wrong? What's the matter with my calculator, right? So watch what happens. Okay, what did I do?
Clear.
I deleted one of the entry at the bottom, right? So that means I have an X but no Y value. Okay, so see what information is gonna, so I can just go here, I can change my window as normal. Okay, what do you think my window should be?
Min is 0, X min is
Min, X min is
0.
0. What do you think this is the X max?
Maybe 5.
Maybe 5? Yeah, maybe 5. Yeah, that's a good one. X scale?
0.5.
On our graphing calculator, yeah, we could do 0.5 on our. Yeah. I put 1. Yeah, for now. Yeah, might be different for. What about Y min? 0. What about Y max?
80.
20. Is everybody okay? 20? Yeah, everybody put 20. Could be 18. That's okay too. What's the Y scale? 1. Okay, good. 1. You could put 2. Okay. So I'm gonna fix that. So I'm gonna go 0 for X min. X max is 5. 1. 0. 21. Okay. So what did I do? In my head, I typed in all the information, but remember, I forgot
1.
to put 1, okay, and I forgot. So I press graph. Oh, okay. So what's happening?
Mismatch.
Some kind of an error. So when you have an error, dimension mismatch, it kind of tells you something is not matching, and the reason why it's not matching is because I have an X value but missing a Y value. Okay, so when you see something like this, kind of go back and see what happened. Okay, because you're gonna come across an error, and it's for you to figure out what just happened here. You can't say my calculator is broken. You can't say that. Okay, here's another error that you might see. Okay, here it is. I'm gonna quit that. I'm gonna enter the last bit. So it would have been like that. But what if I go, okay, I'm gonna stop here for a second. What if I switch my X min and X max around? What if I put 5 here and 0 there? Okay? Well, does that make sense to us?
No.
Because minimum means smaller, maximum should be bigger, right? This one doesn't make sense. But what if we made a mistake? Okay, we were in a rush, right? And then typing it in. And then let's press graph. Okay, what kind of information is saying? Oh, there's an error. Well, what's the error? It's telling you check your window. Check your window. There's an error in the window. And then you go check the window. Okay, you say, what's wrong with my window? Oh, you gotta quit first. And then you go window. And then you check, like, what's wrong with my window? Oh, now I get it. I mixed the min and max around. So it should be 0 for min, 5 for max. Okay, good. Okay, here's the other thing too. Okay, I'm trying to touch on certain areas where you can go like, what just happened? Okay. I'm not showing you what I'm doing because I want us to figure it out. So let's say I typed it in. Everything is there. I typed it in correctly. I changed my window. My window is correct. And then I was like, okay, now I'm graphing. Then you go like, oh, what did I do wrong? Why is it blank? Like what? Why is it? Yeah. So what's wrong with this? Like I changed the window according to the data. I entered the stat plot, so it should be there. Yeah. So it could be that the stat plot is off. So how do you turn it on? Second function, y equals. Okay, now you go stat plot. Oh, it's off. That's why I can't see it. So enter. Can you see off is highlighted? So you gotta press enter. Now it's the on is highlighted. Let's see. Oh, now it's there. Okay, we're taking our time to talk about these things because now in the test, during the test or during the exam, you don't want to have that situation happen to you and you're in a panic because you can't go on anymore, right? We're taking our time to talk about these possible errors so that you know what to do and how to fix it, to troubleshoot. Okay, so that's the thing. Okay, so describe the trend. What's happening to the trend? There's no trend. Okay, well, I'm gonna point out the trend and then we'll talk more deeply and discuss this more into detail. But this is what the trend. As time goes on, the height of the ball increases. So that means it increases. And then after that, it starts to decrease. That's like the ball going up the air and then falling down the ground because there's such thing as gravity. Okay, so describe a trend. The height increases to the maximum to the maximum, and then fall down again. Okay, so we're not going to talk about that like in detail. Right now we're just looking at the pattern, looking at the situation, and that's basically what's happening there. Okay, so that's one skill to enter the data on the graph. Then what's the other skill? It's a different skill, different thing to graph it on a graph paper. So we have graphed it there on a graphing calculator. Now we're going to graph it on a graph paper. Do you think we're going to end up with the same scaling? Okay. I don't know. We'll see. So let's try that. Let's try plotting these on a grid. Okay, we're going to try to make it as big as possible, to use up the whole graph as possible, so it's easier to see, easier to read, and then easy to plot. Okay. I'm going to do the x-axis. Okay. Okay. We're going from 0 to about 3.1. Okay. On a graph paper, what do you think is the appropriate scale? What do you think is the appropriate scale? What should we go up by?
Maybe 1.5.
1.5? Now, 1.5 might be a little bit hard to graph. Okay, so if we go by 1. 1, 2, 3, 4, 5. That's like really, really tiny sliver, right, of our graph. Okay. How many did you skip? Yeah, okay. What we could do is we can go by 4 or by 5. Okay. Now, I'm going to ask you, if I go by 5, okay, listen up. If I go by 5, if I go 1, 2, 3, 4, 5, and that's 1. What's the scaling in here? What are you going up by? If it's by 5. Is it 0.5 each? 0.25. Okay, 0.25 would be 0.25, 0.5, 0.75, 1. That would be 1 there. It would have been 2? 0.2. 0.2. It's 0.2. Okay? Because it's 0.2, 0.4, 0.6, 0.8, 1.0. 1, 2, 3, 4, 5. So that's 2. 1, 2, 3, 4, 5. That's 3. 1, 2, 3, 4, 5. That's 4. Okay.
Is that Y or X? Is that Y or X?
Oh, on the X. On the X. Okay. So each one is 0.1. Okay. Good. Can you see it's different on a calculator than the graph paper? I can't just teach you how to do this on a graph paper. I'm sure I'm shortchanging you if I don't teach you this. Okay? If I don't teach you properly in this, then how are you going to do this in science when it's more as expected? We're taking time now. So, going up by 2. What should we go up by for the y? Okay, so we're going to go from 0 to 20. What should we go up by when we graph it on a graph paper? 2? Okay, let's see. Let's just count. You know what? Right now, if we go 2, so 2, 4, 6, 8, 10. So that's going to give me 10 right there. 2, 4, 6, 8, 10. That makes it 20. Okay, well, there's lots of room up here that we're not utilizing. So should we increase it or decrease the scaling? Decrease, huh? Decrease. So instead of 2, we can go by 5. Oh, then that's going to make it even smaller. It's going to be 5, 10, 15, 20. That's even smaller. So we can go by what should I go up by so that the graph not too big and not too small? 1. Okay. Can I do 1? Do you think it would fit? Yeah. So 1, 2, 3, 4, 5. So scale is 1 because you're counting up by 1. 1, 2, 3, 4, 5. So that's 10. Yeah, you know what? Hold on. I'm just in the middle of something. I want to finish this off. Just put it there. Okay, so now we got our x and then the y. Now here's my question to you. Do the scaling on the x-axis have to be the same thing as the scaling on the y-axis? It could be different, yeah. Because we already talked about this earlier. Me and her. And she. Okay, yeah, it could be different. And as you can see here, what is our scale in here? We went up by 0.2, and then this one is 1. So they don't have to be the same scaling, as long as it's consistent. Okay, now let's go ahead and plot these points. So the first one is 0, 7. So 0, 7. Okay. If your scaling is nice, it's easier to graph. 0, 7. The next one is 0.5 and 13.1. 0.5. So where's 0.5 in here though? That's a question. Where's 0.5? Where's 0.5 in here? Okay, the third one?
Third one.
Okay. I'm going to write this down. This is 0.2, 0.4. Third one? 0.6, 0.8, 1.0. Where's 0.5? If we go third one, that's 0.6.
0.4,
In between 4 and 6. 4 and 6.
Yeah, in between 0.4 and 0.6, between the second and the third. Okay, so that's 0.5, 13.1. So where would the 13.1 be? So we know that this is 10. What would this be? 11, 12, 13, 14. Where would the 13.1 be? Between 13 and 14, but it's closer to 13. Okay, so you can see a lot more thinking. We're not just punching in numbers on a calculator. So 0.5 and then 13.1. So 13.1 right there. Did I do that right? No, off by, so 0.2. Oh no, it should be over here. Yep. Yeah. Oh, this line here at the bottom is x. Is the time. Yeah. So time in seconds. So 0.5 would be over here in between 0.4 and 0.6. And then 13.1, so 13.1 would be up there. Okay. Where would the 117, because that's the next one. 117. So 1 is here. 17 would be up here. 15, 16, 17. Yes? Okay, next one. 1.2 and 17.8. So where would that point be? 1.2 and 17.8. So this is 1. Where's 1.2? Third one? Second one? Where's the 1.2? Remember, this is going up by 0.2. So this is 1, 1.2. So 1.2 is the first line. Okay, so 1.2, 17.8. So where's 17.8? Close to 18, yeah, close to 18. Okay, the next one is 3 and 7.4. So that one's easy. 3 is here. 7.4. So 1, 2, 3, 4, 5, 6, 7. 7.4 would be between 7 and 8. And then the last one is 3.1 and 5.5. Okay, where's 3.1? Where's 3.1? The first line here. This is 3. What's the first line after 3? 3.1. It can't be 3.1. 3.2. Because remember, each one is 0.2. So where's 3.1?
In between 3 and 3.2.
In between 3 and 3.2. So 3.1 is in between. And then we have to go 5.5. So where would the 5.5 be? 1, 2, 3, 4, 5, 5.5. Okay. So the graph goes like that and then falls down. So we have the time for x is measured in seconds, and then height of the ball is in meters.
We connect each other for
Right now, we will, that's where we're gonna head after this unit. Okay? After this unit, that's where we're gonna be headed. No, we're after this lesson. That's where we're gonna head. Okay? Did we do the best job ever? Or is there something that we forgot? Naming the graph, titling the graph. Okay, so the title of the graph would be height of ball versus time. If you want to put the word graph. Height of ball versus time graph. Good. So how do you feel about that? Yeah? You agree? It's good? Okay. We're training ourselves here to graph with technology and also to graph without technology. You need both. You need a balanced knowledge. Okay. So I'm gonna leave that with you. Tomorrow, so now you can do the rest of the assignment questions on your own. Okay, you can do it on your own, describing the trends. Tomorrow we're gonna do the determining regression equations. And we're going from there. Okay.